Hi everyone, welcome back to my channel. I'm Vanshika Verma, and in this video we will solve my second question from my second internal, which is give algorithm or Python or R code snippet at suitable place for following task. The first one is data preprocessing. So data preprocessing is convert raw text into TF-IDF vector for further analysis. So let's see the Python code snippet for it. So in this code, firstly we are importing the pandas library, which is a popular library for data manipulation and analysis in Python. The ASPD part assigns the alias PD to the panda library, so we can use PD instead of pandas to refer to it. And then we are importing TF-IDF vectorizer from class from the skitlearn library, which is this, which is a popular library for machine learning in Python. The TF-IDF vectorizer class is used to text feature extraction. Next, we are importing trend test split function from skitlearn library, which is used for splitting data into training and testing set. Now, we are creating the example data. Data equal to text and label. So this creates a dictionary called data, in which two keys are there, text and label. The text key maps to a list of three text string 1, 2 and 3, and the label key map to a list of three label string theft, robbery and accident. Df equal to pd dot data frame data. This create a panda data frame called df from the data dictionary. A data frame is a two-dimensional table of data with rows and columns. Then text preprocessing, TF-IDF equal to TF-IDF vectorizer creates a TF-IDF vector object called TF-IDF with two parameter stop word English uh, parameter tells the vectorizer to ignore the common English words like the and etc. to don't add much value to the text analysis, and lowercase parameter tells the vectorizer to convert all text to parameter. Then x equal to tf-idf dot fit transform uses the tf-idf vectorizer to transform the text data into the text column of the data frame into a numerical representation. The fit transform method fits the vectorizer to the data and transform it into a matrix of TF-IDF feature. Y equal to DF label, extract the label data from the label column of the data frame and assign it to a variable called Y. Then splitting the data, xtrain, test, ytrain, ytest splits the data into training and testing set using the train test split function. The function takes four parameters: the feature x, the label y, test site equal to 0.2, which means 20% of data will be used for testing, and the random state equal to 42, which means 42 is a random seed for reproducibility. The function returns four array: the training feature of x train, the testing feature of x test, the training feature of y, uh, and the testing label of data of y test. Then printing the x train shape and x test shape, which is this. Now move to the next next point, which is classification. So classification implements a random forest classifier to categorize the complaint. Let's see the Python code snippet. So in this code, firstly we are importing the libraries. So firstly we are importing the random forest classifier class from skitlearn library, which is a popular library for machine learning in Python. The random forest classifier class is used for classification task, and then we are importing the classification report function from the sklearn library, which is used to evaluate the performance of a classification model. Then the classification model part, CLF equal to random forest classifier. Create a random forest classifier object called CLF with a random state of 42. The random state is used to ensure reproducibility of the result. CLF.fit xtrain ytrain. This trains the random forest classifier model of the training data xtrain and ytrain. The fit method takes the feature data xtrain and the label data ytrain as input and trains the model to learn the relationship between the features and the labels. Then coming to the part prediction, ypred equal to clf.predict x test. This uses the trained random forest classifier model to make prediction on the testing data X test. The predict method takes the featured data X test as an input and return the predicted labels. And then the evaluation part, uh, the print classification report Y test ypred evaluates the performance of the random forest classifier model by comparing the predicted label ypred with the actual label Y test. The classification report function returns a report that includes precision, recall, F1 score, and support for each class, as well as the overall accuracy. The report is printed to the console. So the classification report provides a detailed evaluation of the model's performance, including precision, recall, F1 score, and support. By examining the classification report, we can gain insight into the model strength and weakness and identify areas for improvement. So moving to the output. So output will be the classification report generated by the classification report function in sklearn library. So the output says the robbery has a precision, recall, F1 score and support of 0.0, which means the precision has no true positive and all false positive. Recall says no true positive, all false negative. F1 score says no true positive, all false positive and false negative. And the support 0 says there is no sample in the robbery class. Now moving to the theft class, which says as same as robbery. Now moving to the accuracy. Accuracy is 1.0, which says perfect accuracy, all sample correctly classified. Now macro average says 1.0, uh, and weighted average is also 1.0. So the model has perfect precision recall and F1 score for the accident and theft class, but zero precision recall and F1 score for the robbery class. The overall accuracy is perfect, but the macro average metrics are lower due to poor performance of the robbery class. The weighted average metrics are perfect because the support values for the accident and theft class are higher than the robbery class. So now let's move to the third point, which is clustering. So clustering is grouping similar complaint into cluster using k-mean. So now let's see the Python implementation. So the code in which firstly we are importing the k-mean class from sklearn library, which is used for clustering data. Then clustering with k-mean, num cluster equal to 3. This line sets the number of cluster to 3. This is the hyperparameter that needs to be tuned for optimal performance. Then k-mean equal to k-mean n cluster equal to num cluster random state 42. This create a k-mean object with a specified number of cluster and a random state of 42. The random state is used to ensure reproducibility of the result. K-mean.fit x to array. It's use dense matrix for clustering. Method is used to convert the sparse matrix X to a dense matrix, which is required for clustering. Then moving to cluster assignment. Cluster equal to k-mean.label. This retrieves the cluster assignment for each data point. The label attribute of the k-mean object contains the cluster label for the each data point. Then print cluster assignment clusters, print the cluster assignment for each data point. So firstly we understand what is happening behind the scene. So the k-mean algorithm initialize the centroid of this cluster randomly. The algorithm then iterates through the data point and assign each point to the cluster with the closest centroid. The centroid are then updated based on the assigned data point. The process is repeated until convergence of or a specified number of iterations. So the resulting cluster assignment can be used for various purposes such as data visualization, anomaly detection, data compression. So the choice of the number of clusters is critical and can significantly affect the result. There are various methods to determine optimal value of K, such as the elbow method, Silhouette analysis, and gap statistics. So the output is cluster assignment 210. This means that the three data points have been assigned to three different clusters. The first data point is assigned to the cluster 0. The second data point is assigned to the cluster 1. The third data point is assigned to the cluster 2. So in other words, the k-mean algorithm has identified three distinct clusters in the data, and each data point has been assigned to one of this cluster based on their similarity to the other data point. So the interpretation is cluster 0. This cluster contains the first data point which is likely to be similar to the other data point in this cluster, and same for the other clusters. To gain more insight into the cluster, we can analyze the characteristic of data point in each cluster, such as their features, values, or other relevant attributes. This can help us understand the underlying structure of the data and identify patterns or relationships that may not be immediately apparent. So now let's move to the fourth point, which is decision tree. So decision tree visualizes the decision making rules for classification. Now let's see the Python implementation for decision tree. In this, firstly we are importing the decision tree classifier class from the scikit-learn library, which is used for classification task. And then we are importing the export text function from the scikit-learn library, which is used to visualize the decision tree in a text format. So DTCLF, this line create a decision tree classifier object with a random state of 42. The random state is used to ensure the reproducibility of the result, as we have talked about previously. And the DTCLF.fit trains the decision tree classifier model to the training on the training data xtrain and ytrain. The fit method takes the feature data xtrain and the label data ytrain as input and trains the model to learn the relationship between the features and the label. Then tree visualization in the text format. So text rule equal to export text uses the export text function to visualize the decision tree in a text format. The function takes the trained decision tree classifier model DTCLF and feature names tf_idf.get feature names out as the input and return a string representation of the text of the decision tree. Then print a tree rules. This line prints the decision tree rules in a text format. So now let's understand what's happening behind the scene. The decision tree classifier model is trained on the training data and it learns the relationship between the features and the labels. The export text function is used to visualize the decision tree in a text format. The function traverses the decision tree and generates a string representation of the tree, including the feature names, the split value, and the predicted labels. The decision tree rules are printed in a text format which can be used to understand the underlying logics of the model. So the text representation of the tree is this. So this text representation of a decision tree which shows the rules used to classify data points into different classes. So the tree has two features. Feature 2 and feature 4. The tree has three classes: accident, robbery, and theft. Theft. So this decision tree provides a simple and interpretable way to understand the relation between the features and the classes. Now let's move to the fifth point of the question, association rule mining. So association rule mining finds relationship between items in transactional data. So let's see the Python code snippet for it. So in this code, firstly, we are importing the a priori uh, and association rules function from the ML extend library, which is used for frequent pattern mining and association rule learning. And then example transactional data. Transaction equal to mobile theft store robbery highway accident mobile theft store. This defines a list of transaction where each transaction is a list of item. Then convert to one-hot encoded data frame in which DF trans converts the transactional data into one-hot encoded data frame. So PD data frame transaction.stack function creates a data frame from the transaction list and stacks the item into a single column. And pd.get dummy. This hot encodes the item in the stacked column and group by level equal to 0 dot sum function groups the one hot encoded data frame by the original transaction index and sum the values. Then frequent item sets dot equal to a priori uses the a priori function to find frequent item sets in the one hot encoded data frame. So min support equal to 0.5 sets the minimum support threshold to 0.5, which means that an item set must appear in at least 50% of the transaction to be considered frequent. Use column names equal to true. This tells the a priori function to use the column name of the dataset as the item names. Then association rules. Rules equal to association rules uses the association rule function to generate association rule for the frequent item set. So here metric equal to confidence sets the metric for evaluating the association rule for confidence, which measures the probability of the consequent given to antecedent. Minimum equal threshold equal to 0.7 sets the minimum confidence threshold to 0.7, which means that an association rule must have a confidence of at least 0.7 to be considered valid. Now printing the rules. Association rule function को print करता है ये. So the output is a data frame containing association group with column for the antecedent, consequent, support, confidence, and lift. So here the confidence is the probability of the consequent given to antecedent, that is the proportion of transaction that contain the consequent among those that contain the antecedent. Left is the ratio of confidence to the prior probability of the consequent, that is extent to which the antecedent increase the likelihood of the consequent. Representativity measures how of the well the rule presents the data, calculate as the product of antecedent support and the consequent support. Leverage measure of how much of the rule contribute to the overall support of the consequent, calculate as a difference between the support of the rule and the product of the antecedent support and consequent support. Convection measure how the confident we can be in the rule, calculated as the ratio of the left to the prior probability of the consequent. And this matrix is a matrix of matrix that combines the left and the conviction to evaluate the strength of the rule, and this measures the similarity between the antecedent and consequent, calculate as the size of intersection divided by the size of the union, and certainty measures how certain we can be in the rule, calculated as the ratio of the confidence to the prior probability of the consequent. And this is the matrix that combine the confidence and the lift of the evaluate strength in the of the rule. So in this case, theft to mobile and antecedent confidence is 1, which means 100% of transaction that contain theft also contain mobile. And left 2.0, the presence of the theft doubles the likelihood of the mobile. Representativity 1, the rule represent 100% of the transaction that contain both theft and mobile. Leverage 0.5, which means the rule contributes 25% of the overall support of mobile. Conviction is INF. We can be infinitely confident in the rule. And this matrix is one which means the rule has a high Zhang metric value. Jack card is 1, which means the antecedent and the consequent are identical, and certainty is 1, which means we can be 100% certain in the rule. And this means the rule has a high uh, this value. And 2, mobile to theft, the confidence is 1, the left is 2, all things are the same. So this matrix provides additional insight into the strength and significance of the association rule and can be used to evaluate and compare different rules. So this is the answer for the second question. We have seen the all Python codes for it and understand it. In the next video, we will understand the third question of the of my internal 2. Till then, meet you in my next video. Till then, keep smiling, keep exploring. Bye bye.